Okay, so I've been having a lot of trouble getting through this problem in less than 5 minutes. So I drew a few things ahead of time. The scenario is that we are trying to push a basket that's full of baby doll arms. We're trying to push it up an inclined plane so that we can load it into a truck and donate it or recycle baby doll arms. All right, so the basket full of baby doll arms is equal to 33 kilograms. The inclined plane has a 25-degree angle here, and what we want to find is the coefficient of frictional force. That's mu. That's what we want to find. Also, we need to know that this object is moving at a constant velocity. This implies that the applied force, F sub A, the applied force is equal to the frictional force, F sub F. I'm going to write it as F sub F. If the applied force was larger than the frictional force, then the object would be stationary, but it's not. In our case, we're pushing it up. All right, I went ahead and drew the forces on the object. This is the basket. We have gravity going straight down, and our gravitational force is m as mass times gravity equals weight. All right, straight down. Then we have our frictional force is not helping us push this up the inclined plane. Frictional force is going to go down. It's going to go down, and that's F sub F. And then opposing the frictional force is going to be my parallel force, and that's a symbol. It's a little parallel symbol, F sub parallel. And this is my x-axis. This is my x-plane because it is the surface of the ramp and the plate between the two objects. All right, the last force that I need to talk about is going positive in the y direction is our normal force. I wrote it as F sub n. Opposing that is our perpendicular force, F with this little perpendicular sign. All right, now we need to put in terms of all the forces on our x-axis, the summation of the forces on our x-axis. What do we have? We have frictional force going this way. So, and we also have parallel force. So we'll take the frictional force, subtract the parallel force. And that should be equal to 0 because we're at a constant velocity. Y-axis. All right? On the y-axis, we have a normal force right here, and we have a perpendicular force. So we're going to say normal force minus perpendicular force. Also can be set equal to 0. Now we can express some of these things in terms of mass and terms of our mass and our angle. All right, so if this is our parallel force, all right, and then straight down, we've got our gravity, and that's our hypotenuse. Okay. Okay, so then the parallel rule says that we can take this frictional force, draw a parallel line this way, and then we're head to head, it should have been the arrow. So that is F sub F, frictional force. All right, going this way. This is our angle now. This is the angle. Now, so therefore, we want adjacent over hypotenuse. So what are we going to use for that? Cosine. That's going to give us F parallel equals the weight times cosine 25 degrees. Now our weight, what is our weight? Can you see? All right, what is our weight? Let's see. Weight equals our mass. What's our mass? 33 kilograms. 33 kilograms times gravity. 9.8 meters per second squared. And we're going to do this equation, and it comes out to be 323.4 newtons because kilogram times meter per second squared is newton. All right, so we're going to come over here and put this value in here, 323.4 times cosine 25 degrees, and this is going to be 293.1 Newton. All right, now frictional force. All right, we're gonna have our frictional force, and we're gonna, instead of cosine, obviously, the opposite of cosine is sine. W sine 25 degrees. All right, sine 25 degrees. Can you still see? And this is going to be frictional force 293.1. Oh, you know, I think I copied my numbers wrong. I'm sorry. Because I plugged it into the calculator earlier. It's actually 136.7 newtons. That is our perpendicular force. Okay? Down here, it comes out to be the 293.1 newtons. Okay? So now, now we need to use the F. Frictional force is equal to your coefficient of frictional force times your normal force. Times your normal force. And with this equation, because we have the frictional force right here, can we find this? This is the normal force. It should be equal to our perpendicular force if we're in a constant velocity. So we're going to go ahead and plug in these. 293.1 newtons equals mu times 136.7 newtons. And so then we're going to have mu divided. This comes out to be about 2. It's actually 1.9 something. But it's about 2, and that's actually a large coefficient of friction, which is good because you don't want to slip down while you're trying to carry your basket of baby doll arms.